Hi Alice, yep. How you find your asymptotes, your vertical asymptotes, first of all? I think you said you were all right with that. Um, well, you can't, if you have a fraction, which is a reciprocal basically, the bottom number you can never divide by zero. So you're looking for a situation for for the vertical asymptotes. Is there a situation where that ever gives ever gives zero, and you can't have it because one divided by zero, anything divided by zero, is infinity. So we're let me change my colour. If you're trying to see will x plus 2 ever equal 0, and yes it will, because if you take 2 from both sides, when x equals minus 2 you'll get a situation where this is 0, and as I said you can't have 1 divided by 0. So you know there's a vertical asymptote at x equals minus 2, and we signify that with a dotted line like such, going through um, minus 2. Now the graph will approach this but never cross it, okay, as I'll show you in a second. Now the next thing is to look for horizontal ones, which was your question. Then you do a second technique. The second technique is you let x tend towards, that's what that arrow means. What happens when x tends towards infinity? In other words, when it goes way up here, what's it trying to get towards? So you will end up with a situation of y is equal to 1 over infinity plus 2, and infinity plus 2, well, adding 2 to infinity is having absolutely no effect whatsoever. So that is really saying 1 over infinity. Now, if you've got your calculator and you gradually do make the bottom number bigger, you'll see what happens. 1 divided by 2 will start off as 0.5. If you've got 1 divided by 10, you get 0.1. If you do 1 divided by 100, you can see you get even smaller. So as this number gets bigger and bigger, you know that you're gradually going towards 0. You can see you got 1 divided by, let's do 10,000. You can see that you get, doesn't matter how this number, well, you know the standard form, that is 0.0001. Okay, so you're gradually getting towards 0. So as x tends towards 0, you're looking to find, you're replacing x with infinity and seeing what happens. So if you end up with 1 divided by infinity, because this adding 2 to infinity is going to have no effect whatsoever. So 1 divided by infinity means you've got a situation where this is going to be 0 at the end of the day. So y is trying to approach, is tending towards 0. So that is where your line is. It is trying to approach y equals 0. Okay, so y equals 0 is what it's trying to approach. So the asymptote for that one there would be the x-axis, like that. Okay, so you've got your asymptotes. That's how you discover your asymptotes. Now you can see what's happening because you can do x tends towards positive infinity. I should really put, if I'm going to be technical about this, you could call this positive infinity. In other words, you're talking about up here, then it's tending towards 0, and you can see positive infinity is always going to be a positive number. This as this grows, it's always going to be a positive number. So this is always kicking out a positive number. So it is always coming from the positive going down. It won't ever get, that will never, this calculation will never be 0. So you know that it's approaching that, and it's approaching that, never touching it. And realistically, you should also look at this one here where x tends towards negative infinity. So you end up with a situation of y is equal to 1 over negative infinity plus 2, and that plus 2 is having no effect, so it's 1 over negative infinity, which is really negative 1 over infinity, which is 0. So because this will always be negative, x will always be negative, then it's approaching from this way. Okay, so it's going up like that and approaches there. X is negative infinity is down here, right, and positive infinity is up there. So negative infinity is down there. So that's all you do to find the horizontal asymptotes. I hope that helps. Okay, you look at these two things, negative infinity, positive infinity, and find out what it's actually doing to the, what is there a limit it's trying to approach. Okay, I hope that helps. Let me know.